Nice to see a good attendance. Dr. Rajaram actually spoke a few months ago in February, and quite a few members of our department attended that talk. I was not honored enough to be able to go to that talk, but there was a lot of positive feedback. Everyone was really excited about the talk, that it was an excellent talk. And so we're really thankful that you were able to reschedule and come and speak to us directly. So she is speaking to HU today. Dr. Rajaram has been a professor at Stony Brook University since 1993. And she has also played a really important leadership role in our scientific community. And I think this is also very important on top of the research excellence. And so she is the president-elect of the American Association for Psychological Science. And something that's personally important, you've also played a very important role in advancing women in cognitive science. And so we appreciate the leadership that you've taken on that. She has funding currently from the National Science Foundation, and the title of that is Mnemonic Transmission from Small Groups to Social Networks, and so I think it's going to be part of the talk today. And then this intrigued me. You have funding from Google Faculty Research Award. And again, something that is important to our science here in our department. The title is Aging and Finding Information, Using Google versus Relying on Other People. I find that title really intriguing. So those are her current funding right now from both the federal government and privately. And the science that Dr. Rajaram does is the science that she'll be presenting today. She actually has many facets of her science, but the science that she is going to present today is the role of social factors in remembering. And this is relatively new in sort of the cognitive science of memory. And so it's a novel perspective that is sort of gaining traction in the field. And that's okay. Hi, Jane. Jane's here. So what has intrigued me about that science and the idea of social factors in remembering is that the fact that we start to have a collective memory. And that collective memory isn't always necessarily for good in terms of the details we recall, that idea of the inhibition and collective inhibition. And that reminds me of a talk that I saw in Jewish studies where a historian was using many different sources for the memories of Jewish victims of World War II. And it was interesting to hear him use the language of memory and what kind of prompts they had, whether they were part of different cultural groups. So the Jews in LA gave a totally different recount of the same camp as the Jews that are in New York City. And so the idea that social factors something as powerful as remembering the trauma of World War II can be also modulated by social factors. And so I always think of that. And he also showed something very similar in the fact that there were less details or sometimes misinformation even from these social factors. So this is a very powerful form a powerful form of influence on our memory, and it's important that we're looking at these factors now. The title of today's talk, it's a long one.
Why did it go forward?
Yeah, probably because I'm taking too long. Social transmission of information and emergence of collective memory, cognitive mechanisms, and network structure. Thank you. Please welcome Dr. Ross.
Thanks very much. It says I'm 10 minutes into my talk. So how are we situated for time so that I can pace myself and leave time for questions?
Until 3:30. You take as much or as little as you need, and we'll just have Q&A to fill in.
Okay, all right. So good afternoon, everyone. How many of you were at my February talk? Nice. Okay, so for those of you who did come to my talk before, thank you. And we know from the testing literature that actually it would have been better if I had you recall my talk than to present it again. But we know that presenting it again is better than not seeing it a second time. So it's all positive. So it's so wonderful to be here. You know, I brought this weather with me. You do know that. And I've had such a great time meeting with everyone. And learning about Cornell and the Ithaca community. And it's a real pleasure. And it's really has been wonderful to learn about different research programs that are going on here. And I also got the perspective from graduate students. So it's just been a very, very informative, enjoyable, and wonderful visit so far. So I hope I can do a little bit in return in this talk for you so that you get to hear a little bit about a little bit of the arc of my own memory research. And I'll just give a brief introduction in the first 5 or 10 minutes to show where I'm coming from and why I have come to what I'm presenting to you today. So that's the goal. And then I'm going to talk about transmission of information and collective memory. So Eve talked about my interest in social factors, and you will see that in this case, I'm really operationalizing social factors in a very specific way, which has to do with conversation and collaboration. And that sets up the platform and the foundation for then taking it forward to examining what social psychologists and sociologists will really consider the big social factors. And so that's the arc of where I want to go with that. So the fundamental question that I'm asking in this program of research is how memories are dynamically assembled for use by individuals and communities. And I'll separate individuals and communities as I start to unpack the kinds of experiments we do. And I'm interested in studying this question both in small groups and in large social networks, and how the two can be brought together to address the challenge that we take on in my lab of grounding these very complex, large-scale memory phenomena that occur in groups and networks, but doing that using the very well understood psychological processes that we have learned from the last century of research, but definitely the last 20, 30, 40 years. In today's talk, I'm going to focus on 3 aspects of studying this question. One is using the distribution of information. The second, how the memories are actually assembled. And then looking at the individual and community level. Information distribution, why are we interested in this? Because it is very important to know who knows what before we can say what they go away with once they have interacted in a social environment. So it could be the case that there's information that everybody knows. It's common to everyone. And then there are times when there's information that only some people know but not others. But that information nonetheless spreads. And what is the consequence of that spread of information? What in traditional psychological research or memory research we call false memory, something that you were never exposed to but now has become a part of your own mental representation. Dynamic assembly, what I mean by that here is the process of collaboration. When we talk to others about our past, what's the consequence of that? The intuitive sense is that when we talk to others, we augment our memories. But it turns out that you can also distort your memory, you can suppress or lower your memory, and you can also correct your memory. So there are multiple different consequences that may or may not be intuitive in the beginning. And so there's a certain dynamic change that goes on in the way memories are reshaped as a function of collaboration. The assembling of memories also depends on the size of the group. So the size of the group can change what is remembered and what is forgotten, and the structure of the group, what in social networks we often refer to as topology, of that network that can change how these memories are adapted over the course of the conversation. So the structure, the network structure, refers to some of the topology that occurs in groups, but also whether we are talking to the same people all the time or whether we are in a wider dispersed network where we talk to different people at different times. So we can imagine this as a prototype of different communities or societies where people inhabit more insular groups or more diverse networks in which they spend their time. And the fourth point here is very basic research that's going on in my lab right now. Well, all of it is basic, but this is perhaps the most basic of them all, where we are looking at not only how the content of what we remember can change, but also the way we organize that information. So it's not just the content, but also the structure of memory representation that can change. We know that from individual memory research that structure of memory can be reshaped through different forms of encoding and retrieval. In this program of research, we're interested to see how interactions with others can change the structure of memory. I'll unfold that more as we go along. And then by individuals and communities, so the consequences of such collaborations and conversations can be assessed both at the level of how it reshapes the memory of a single individual who previously inhabited a group, but also of the community as a whole. And to do that, we can look at the influence of not only those who are our proximal neighbors, with whom we directly interact, but also those who we might call distal neighbors. Individuals in our network with whom we never interacted, but with whom we share a neighbor. And through the sharing of that neighbor, the influences can hop across degrees of separation. And as a result of these interactions, there can emerge a convergence in what people know in a group or in a community, so that they may not have met each other, but they may hold similar representations of an event, or they might hold divergent representations of an event. And these are some of the properties that can start to come about in groups and larger communities as people interact about the information from their past. And those are the questions that really interest my lab right now in terms of the mnemonic transmission in a connected world. And the implications are multifold. There are obvious implications for educational practices. We, in a very practical sense, we use study groups all the time. Students like to be in study groups. Are they helping each other? Are they, from a cognitive standpoint, are they helping each other, or are they having a very complex effect on what the others are learning in the group? So there are those very obvious educational implications. There are implications for establishing common ground with others with whom we are speaking. Do we come to have a shared representation of a reality or not? And I think psycholinguists are really, and communication researchers are very interested in how common ground is established. There's a lot of interest in how in aging collaboration can help. So as memories start to, as the memory functions start to slow down a bit through the process of normal aging, a very intuitive sense is that having someone else support and scaffold your retrieval of the past can be helpful. But if we understand the process of collaboration, then we can really know when it can be helpful and when it might not be as helpful. Reshaping of autobiographical memories. This is something that we are directly interested in our lab, where we are looking at how the affective component of an autobiographical memory can be reshaped through collaborative recall of that memory. And Eve talked about some of the social, cultural, and national issues where the identities of groups can be changed or shaped by the kind of collective representation these groups come to hold, depending on whether they are in one region of the world or another. And there's the shaping of public opinion, especially now with the proliferation of social media, how public opinion can be shaped as a result of transmission in large networks is also something that can be better understood by having a very controlled approach to understanding memory transmission. And that connects to transmission of that could potentially connect to transmission of behaviors. So from the discipline of sociology, there's a lot of interesting research coming out that I think many of you will know very well, where behaviors such as stress, even cancer, smoking, behaviors like that seem to be interconnected in large social networks, such that those who are in your immediate network, people exhibit similar behaviors. So why do people exhibit similar behaviors? A possible reason for that is when people share information, the information sharing serves as a basis for behavioral choices. So there are potential for understanding a number of different practical issues that emerge as a result of the social life that we have. And one of the goals in this research program is to understand how information transmission and memory transmission can serve as a basis for many of these major phenomena that interest us in human development, in psychology, in sociology, and disciplines like that. So the interdisciplinary interest in socially situated memories has been not just in psychology. In fact, psychology is late to the party, I would say. It has been of great interest to sociologists, as you would know, philosophers, for historians and anthropologists, and a number of different concepts like the ones that I have listed on the right side, your right side of the screen, have been considered in trying to understand socially situated memories. Within psychology, there is developmental work where memory scaffolding has been a very major theme in understanding how, for example, mother-child interactions can shape the memories of children. And in social psychology, conformity, persuasion, transactive memory, there are a number of other different ways in which social psychologists have approached this question to understand how others can influence the memory representations we start to have. There are many reviews in psychology where some of these histories have been covered. So this has become an increasingly interesting question in the area of cognitive psychology, where I sort of sit. But a lot of these interdisciplinary interests in groups and social networks come from a number of different areas within the social and other sciences. And the approaches have also varied. There are experimental methods, there's network science, and there's modeling, especially agent-based modeling that has been used to understand some of these large-scale effects. So from the perspective of how people in general think about social influences, surveys show that both young and older adults view collaboration as being more beneficial for remembering than working alone. So whether we look at study groups or there's research on work teams, whether we talk about friends and families, the general sense is that working with others is more beneficial than working alone. So this is a very powerful intuitive sense. And the idea that socially transmitted memories can really shape what people think has been around for a long time. And starting with Bartlett, who was just as attentive to the social aspects of it as the experimental part of memory changes, there was a sense that we need to understand the social context in which memories change. But at the same time, the research in cognitive psychology on memory came to be dominated by the Ebbinghausian approach. It's not because Ebbinghaus did not recognize the importance of social influences. It's precisely because he recognized the influence of social influences, and it took the approach that it's important to control those influences to understand the underlying memory processes rather than actually study them. So there was this sort of different approaches to understanding the social influences, to actually take them head on or to control them. And the influence of Ebbinghaus really led to a big literature on individual memory ability. But in my own work, I'm influenced by both these sort of historical movements, shall we say, to understand how social sharing of memories can influence the memory of the group by looking at small groups, and that's where the experimental work begins. But it then eventually ties to how larger social networks can really begin to show these consequences. So our aim has been to identify the cognitive psychological principles that can explain complex, large-scale memory phenomena. And with that goal in mind, the idea is to understand how memory transmission can have effects on education, on behavior, and on public health. So this is sort of the broad scope of where we are thinking about all of these issues. And to do that, we take an experimental approach. And we bring the phenomenon into the lab and look at how to measure social transmission of memory and its consequences in the lab. So this is the basic paradigm that we use. So let's say that we bring a number of subjects into the lab. In all of the cases I will discuss, the subjects are strangers to each other, and we make sure that they are. Okay? And of course, subjects not being strangers is going to be a very important different directions to take, but that's where we start. And subjects study some information alone, and then they enter either a collaborative group or what I will call a nominal group. So in a collaborative group, typically we have triads of subjects working together to recall the information that we had shown them, and we compare the performance of that group with a nominal group, or a group in name only, where we have an equal number of subjects, but each subject will now engage in recall alone. That's a standard memory paradigm, but we are comparing it to a collaborative group. So let's say the collaborative group recalls a certain number of items, 6 items, and the individuals typically recall less than what a group recalls. Okay? So this is a typical recall of each individual. But to calculate the potential of a group to compare to a group that actually collaborates, what we do is to take out the redundant items across the subjects, pool the recall of the individuals together, and come up with what would be the potential of a similar sized group, and compare that to a group that actually collaborates together to recall what they had seen before. And when this is done, the typical phenomenon is that the nominal group recalls more than the collaborative group, or to put it the other way, the collaborating group recalls less than the control or the nominal group, demonstrating what Weldon and Bellinger called collaborative inhibition in recall. Don't take the term inhibition too theoretically at the moment. We have a whole other line of work looking at whether it's actually inhibition. But the point is that collaborative groups consistently recall less than nominal groups under this condition. So that's the phenomenon. There's been research to show that it's not because of diffusion of responsibility or social loafing. And there are ways people have controlled it in different ways, and this effect does not seem to go away. The main mechanisms that have been attributed to why people recall less, several studies show that it's because of disruption And we've shown that there's actually theoretically, there's also some inhibitory phenomena going on there. But I don't want to go there right now. I can talk about that more later if you have questions. But let me explain the idea of disruption. When we are exposed to any information, we have a propensity to organize it in some form or another. And that has been shown in a number of different ways. So some of this organization is driven by our cognitive past and what we know, and our collective past. Some of it is idiosyncratic to us. So apples and oranges go together for me, but for you, apple may be closer to pear. Okay, so that's a very simple example, but you can then just kind of expand it. So there is a certain organization we impose, and when people start to recall the past together, what I recall may disrupt the particular organization that you have for that same information, and that disruption lowers what you can recall at that time. You might recover it later or not. When you don't recover, it's inhibition. When you recover it, it's still there. But during collaboration, you're disrupted, and you come up with less. It's not because of social loafing, but because of a cognitive mechanism of disruption. So these are some of the mechanisms that lead to lower performance, and that's sort of the theoretical part of the story. But that has some post-collaborative consequences. So when people leave groups and they are on their own and they have to recall the same information again after having collaborated with others, they might show some forgetting because they couldn't recall it during the group collaboration, and now that information is sometimes recovered and at other times lost. Okay? What can also happen is that some information people did not remember was remembered by someone else. Okay. So people get re-exposure or a second study opportunity. So post-collaboratively, their performance can also improve. So that can lead to, so there can be forgetting, there can be re-exposure, and there can also be memory errors. Information that someone else recalled that actually never was a part of anyone's original experience, but someone inserted it, and now it's contagion. Someone else is also remembering it afterwards. So there are a number of post-collaborative consequences that can occur in memory that can change the representation of the past for every single member who was in that group before. So this dynamic assembling of information during collaborative inhibition can have many different cognitive processes underlying that: disruption, forgetting, re-exposure, memory errors. There's also error pruning, where if someone erroneously recalls something, a group member can correct them. So there are, from a strictly memory point of view, there are positive consequences, there are negative consequences. From an adaptive standpoint, the effort usually is to come together to have a joint reconstruction of the past. And from a functional standpoint, that makes a lot of sense because people want to, depending on who you're with, you might want to have an agreed upon sharing of the past. It certainly creates more harmony when it can be done. So these are some of the cognitive processes that we have been mapping in our research. As I have just listed some of the references here. And then there are network influences. Depending on how many people you're collaborating with, how often you get to collaborate with them, who else they are collaborating with to reconstruct the past. Small groups, larger networks, insular networks when you're thinking about the past with the same person over and over again, diverse networks when the neighbors change, and then the influence of those who you directly collaborated with compared to who they collaborated with, and so on and so forth. So your neighbors can influence what you remember. We know that from a lot of research in sociology for behavior. What we are modeling here is in the domain of cognition and how there can be these influences that are direct and indirect. And these consequences can occur at the level of group memory, at the level of an individual, each member's memory, as collective memory. That is, a joint representation of the past, where it's not just the total sum of what a group remembers, but it's what every member of the group shares together as their memory. And there can be diverse memories. People remember different aspects of the event. There can be propagation of false memories, and the whole structure of the memory can change. So these are some of the consequences that we've been studying. What I have underlined here are some of the phenomena that I want to show in the data that I hope to share with you today. We've looked at different types of information for getting an idea about how collective memories and collaborative memories develop. Today, I'm going to focus on emotional valence in particular, and time permitting, some data with categorized word lists. But we've also looked at general knowledge questions. We have looked at some learning of statistics. We are looking at autobiographical memories now. And of course, unrelated word lists are always the handiest of them all. So in the study that I want to talk to you about, we looked at two main questions. Well, these are two different studies, actually, network structure and the structure of memory itself. So I want to talk about the network structure and its influences first, and we'll see then if we get to the structure of memory. This work was led by Hae-Yoon Choi in my lab, who's now a postdoc at Yonsei University, and with my colleague at Boston College, Elizabeth Kensinger. Here, I want to talk about three dimensions of the study that we manipulated. What information people see, what the structure of the group is in which they recall this information, and how the information is distributed across people who are in that group. So what information people see. In this particular work, we focused on emotional valence, or whether information has some positive or negative or neutral valence. From a very large literature on individual memory, we know that people remember negative information and positive information better than neutral information. The reason we wanted to use this particular attribute of what people remember is because we know from other lines of work that emotion stimulates conversation and social life. So when we are looking at how people collaborate, they might be more drawn to emotional than neutral information, and that gives us a little bit more variation in what we can understand about this process of collaboration. And there's also work to show that the inclination to transmit information is greater when information has some valence to it. So for these reasons, we decided to look at emotional valence. This has broad implications for discussing and remembering unpleasant or pleasant news, information, and spread of gossip and social media. And when information is more valence, there's more group activity surrounding it in terms of information transmission and sharing. So to control and manipulate this particular dimension, we used categorized pictures with labels, and we had an equal number of information in each valence category. So a picture of a hyena and its label would be a negative stimulus. A cow would be a neutral stimulus.
Not for some.
Yes, there are very important individual differences that would be the first thing to recognize here. Well, yeah, I mean, if you have severe allergies to cats, the last one might not work either. But on average, this seems to work. No, Chuck is not convinced. He's okay, and we have shown that it works. We have data from multiple papers. Okay, so this is the type of information that people study, and these are all the details of how we selected the stimuli. So, and then group structure. Okay. Why group structure? Why are we interested in it? Because we have seen in our previous work that group structure can change the flow of memory. Okay? So in this paper, also led by Yoon Choi in my lab, we looked at the effects of group configuration on social transmission of memory. And what we mean here by group configuration, I will show you in great detail by comparing identical and reconfigured groups. And let me give a little plug to my graduate student, my former graduate student, Yoon Choi, who got the Best Paper of the Year award for this particular work. And you will see that this is not easy work that Yoon did. So subjects study a list of words alone, and then there is a whole sequence of events that happen in a standard distractor task in a memory experiment, and then 3 recall sequences and a recognition task in the end. I'm not going to talk about all of these. I just want to introduce the design to you because this will become important for the study I actually want to discuss with you. The control condition is always individual recall, and interest here is in the 3rd recall. The middle condition shows a standard collaborative condition. People collaborate together to recall what they had studied before individually, and then they recall again in the same group, and then they go off alone and recall alone. Okay? So the 3rd recall is always similar. This was the interesting group that we introduced, the new condition we introduced here, where 3 subjects recall. So the first recall is similar across these 2 conditions. In the next group, the partners change. Okay? Initially, everyone was exposed to the same information, but now the partners change in this manner. So in the identical group, it's the same group recalling twice. In the reconfigured groups, again, it's triads recalling as groups, but next time this particular individual has 2 different partners. So as a result of this, the number of opportunities that any given individual has is constant. You always collaborate with 2 partners, you always collaborate twice. But the influence on any given individual is that of 8 partners, 4 who are the proximal partners for this individual, and the other 4 who are distal partners. So in this way, we can look at the whole, we can create a network in the lab where there are proximal and distal influences, so that eventually there are 9 people who are in this group. So here, when an individual is collaborating with the same partners, it becomes an insular group, and when an individual is collaborating with different partners each time, the group becomes more diverse. So that was the idea here of creating a larger network. So we took that particular design, and this is what I just described to you actually. So I have already told you that there are direct influences coming from immediate neighbors, and there's indirect influences. So this is just the illustration of that idea. So that's the group structure we borrowed from our previous work. And then there's information distribution. Why different distribution? So the idea here is that people have come to their collaborative situation either with the same information they share with all of their partners, but there's some information that each one possesses uniquely. Or a subset of them share, but a 3rd person doesn't know it. So this is sort of to simulate how information distributes differently when we come together as a community. And the question is then, how are we influenced by different individuals in our community? So rarely do all partners bring the same memories to a conversation. And this gives us a tool to measure the propagation of false memories in a very controlled paradigm. So information distribution. Let's say that every individual here has seen the same items, accordion and cello, but in this particular triad, these 2 partners have seen drum but not flute. This individual has seen flute but not drum. So the information is distributed differently, and so some information is shared, some is partially shared, and some is unshared. And we can do the same thing so that with the second time when these individuals come together in this reconfigured pattern for group recall, this individual has seen harp, and the other individuals are likely to recall drum and saxophone, but this particular individual was never exposed to it originally, but is now being exposed to it. But it's not their own original memory. So in this manner, we can create a very complex set of information floating in the network, but we know exactly who had been exposed to what and at what point. So that same thing goes for all of them, and so that we can completely map who knows what and who was exposed to what, and we can also track the recall to see who remembered what at what point. All right, so we are varying the information that people see, we are varying the group structure, and we are varying information distribution. So all of this can be brought together to really create a complex but a very systematic mapping of information flow across subjects. And by doing that, we are also making it very measurable, because we know exactly what happened when and who said what. And by doing that, of course, we get a large number of dependent measures for what we can track as to what happens in this simulated network in the lab. But I'm going to focus on only a few here. The diversity of memory, that is, what's the divergence of different types of memory that people remember having gone through this entire process. The emergence of collective memory, how memories converge so that people who were in a group before, whether they are remembering the same information again or not, and also emergence of false memories. So when people collectively start to remember something that they had never been exposed to before. And a lot of this information comes from the post-collaborative recall stage after all of the collaboration has occurred. Of course, in the actual paper, we have information for every possible stage, but that's what I'm going to focus on today. So this is the design. It should look familiar, I hope. Study alone, then distractor, then 3 recall phases, and then a final recognition. The control group is, again, all individual recall so that we can see what happens here and compare it to identical groups when the groups don't change across 2 recalls, and then its consequence post-collaboratively, and then reconfigured groups where there's this group, and then people exchange partners, and then they go into final recall and recognition by themselves. So that's the game plan. Okay. All right, so variety in recall. What we have here is, in a group, what's the total amount of information that can exist when we pool together what a group remembers. So this is what I originally showed you as nominal recall. Remove all redundancies and see what a group on the whole can recall. Okay? That's what we are looking at here. So we have the control group that never collaborated, identical group that repeatedly collaborated within the same configuration, and the reconfigured group where there are actually there are 9 people in the network. And we have positive valenced information, neutral, and, negative first, neutral, and then positive. And the same layout here. And then what we have is these very solid bars are true recall, and these lighter bars are recall of non-studied items. Okay? So that's what we have on this graph. And what you can see here is that identical group has the least variety in recall. That's another way of saying that people who've been in the same group and recalling in the same group start to show less variety. They're remembering the same thing. And I'll show you that in another measure, in a more direct measure. So in the control group, you can see this gives us the baseline for how much variety can exist in recall. And we can see that the reconfigured groups pretty much looks like the control group. They possess a lot of variety, and we can also see that there is a lot of false memory. That's, well, not lot compared to the true memory, but compared to the other conditions, people are remembering a lot of information individually that they themselves had originally not seen. But they've been exposed to a lot of different people, and they've picked up this information. But remember, this is not the overlap in memory. This is the potential for how much false memory can exist in a network. Okay? Now, having seen this, what I want to show you now is the collective remembering. This is the number of items that people who had previously been in the same group or had collaborated are all recalling the same information, even though they're not in that group anymore. Okay? So this is the shared overlap after all the collaboration is done. So this is how their memories have come together. One would hope that if they had never collaborated, that overlap would be low, and indeed it is. And then the question is, what happens in identical and reconfigured groups? So here people have collaborated with the same two partners over and over again, and here people have changed partners over the course of repeated collaborations. And what we see here is that both group structures increase the overlap, or what is called collective memory, which we can also think of as convergence, when they collaborate either with the same or different partners, and both are greater than never having collaborated. What is really interesting is that collaborating together with the same partners leads people to develop the same shared false memories. So if people are not exposed to different information and the same false information is circulating in the same insular network, people develop more false memories. So there, yeah.
So the paradigm here with respect to false memory is basically, it's a misinformation paradigm. It's a suggestion paradigm.
Yes.
Without the social constraints that are associated with suggestion. So two questions. Do the subjects know that their partners may have been exposed to different lists?
They do not.
Okay, they do not do that. Is there a difference between the consistent group and the reconstructed group? Is this a misinformation repetition effect? That is to say, do the people in this group tend to repeat the things that you weren't actually presented more often than the ones in that group?
Across recall sessions.
Exactly.
Yes, and they do.
Okay.
So when we look at their first recall and second recall, we see this consistency that's emerging. And to answer your first question again, when you asked me, do they know that their partners have seen some information that's different? We debated, should we let them know or should we not let them know? Because we didn't know exactly how to stack the cards, we first wanted to see when people don't know, what will they do? And second is, in the individual experience of any given subject, there's really a small proportion of items that are non-overlapping. So the idea when someone comes up with something, it's much more likely for people to say, it could have been there, I just don't remember. So we thought it would be better to look at suggestibility this way.
It's very good, too, from the point of view of attempting to understand whether there's a fundamental difference between what's going on in social networks relative to the normal misinformation situation, if there's any effects that are different, because you're setting it up in such a way that they are going to assume what's being communicated to them is true shared information, the way you do in a misinformation.
Yes, that's right.
So
it's very consistent with the goals that you just outlined. So what we see here then is that the development of false memories is actually greater when you hang out with the same people all the time. And that has, these are, very controlled stimuli with words and pictures, but there are potential implications for how people come to share views that are not so much incorrect as things that didn't exist, but they become real when they don't share their information with a larger set of people. So this is collective remembering and how this can go awry. Next, I want to talk about collective forgetting. So here, all the individuals who are in a particular group have now all forgotten the same information. That's what we are looking at here. So this is the control group, and this is the baseline for collective forgetting. Again, identical groups, reconfigured groups. The green bars are negative, then the gray bars are neutral again, and the red bars are positively valenced information. And what we can see here is this is the forgetting. Remember that this is the forgetting measure. So the taller the bar, the more the forgetting, and the more collective or shared forgetting. And what we can see here is that people actually tend to collectively forget positive information more. So there is overlap in what people forget, and this is more so in the insular structures. It's true for both structures, but it's a little bit more likely for identical groups than for reconfigured groups. I don't want to overemphasize that point because those differences are small and I would really like to see them replicated. But what I do want, what is very clear to us is that there is consistent collective forgetting of positive information being greater than any other kind of information. So, so what we see here then is that when we vary network structure, when we have different kinds of distribution of information, there are very different patterns we can see. That there is collective memory that exists, that emerges in both types of network structures, but smaller and insular structure promotes more collective memory and more collective forgetting. Collective memory, by the way, is really measured as a combination of remembering and forgetting. I wanted to break it down and to show you where the action occurs. But that's really how, at least currently, the idea is operationalized. And what we also see for false memories is that nearly 20% of the collective memories were actually false collective memories. So people come to share, they have an agreed upon account of the past that actually is not true. I didn't show you the recognition data, but in the recognition data, we reported that in the paper, there's greater confidence that people have when they have been in these insular networks. So both group structures increase collective memory, forgetting of positive information, but collaboration leads to more negative memories later. That's another way of saying it, kind of supporting the idea that bad is actually stronger than good in being able to remember the past together. And we think that this is actually particularly the case for the type of information we have used here. So this is not personally or autobiographically relevant information. And autobiographically relevant information we don't believe is going to show the same pattern. But this is more about something that doesn't pertain to you, that is not important for your self-relevance or self-validation, but something that we see as news or information that's out there in the world. So I want to talk a little bit about structure of memory, because I think this goes deeper into understanding how these changes are occurring as a result of being a part of a social network. What do I mean by structure of memory? Here, as I briefly mentioned in the introduction of my talk, this is not just what we remember, but how we organize that information in our mental representation. And the reason it's important to look at how we organize information is because organization of information makes memories more enduring. When something fits within an organization, it's more enduring than when it does not fit. So, so collaboration during recall changes the content of memory. That's what I've shown you so far. That's what we remember. And the question now is about how we organize these memory, or the retrieval organization in recall. So here's an example of what how organization is typically measured in these studies. So if subjects are presented with a list of items and then they later recall, this is a particular list that does not have much of an organization. Here we start to see that fruits are coming together, and here we see that fruits are all lumped together. So this is an example of greater organization in recall. So why should we be interested in understanding the structure of memory and how collaboration can affect the structure of memory? It's because there is evidence to show that organizing the past can reshape how we encode the future information. So organization assists in encoding new information. So a potential implication then is that when we share this architecture of memory, when we organize information the same way, it can increase in the future how we would similarly encode information. So it's sort of becoming similar thinking people in some sense, if you want to think about it that way. So how are we likely to think about mango? How likely are we to remember mango later on if we had created a fruit structure in our memory compared to if we had not? So there are implications for how we will handle information in the future. So shared memory structures, what I want to do here is make a distinction between within subject structures and between subject structures. So in memory research, there's a lot of work on within subject structure, how each individual would organize information. The leap we are taking here is to see how collaboration can get 2 individuals or 3 individuals to develop the same structure. And that means the potential for them to encode future information becomes very similar. And that means they become more similar thinking. And so this is what would be the implication of that for social networks that begin to coalesce information that way. This is a very large study. I just wanted to show this for the sake of completion. We don't have to go through any of it. All I want to point out is that in the control condition, there was no collaboration as before. In the early collaboration condition, the collaboration occurred early on. In late, it occurred later on. And in multiple collaborations, there was more than one collaboration.
When you talk about collaboration in this particular study, are you just using the same collaborators, or are you talking about a
Thank you for asking me that question. Same collaborators. We are not varying collaborators in this. And we are using categorized lists so that we can measure the structure or the organization in memory. So I'm glad you asked me that question, because that helped me also remind myself that I should point out that detail. Yeah. So it's the same group. No group changes. Okay. So here we are going to look at paired frequencies of adjacent items to measure memory organization. So what's the likelihood? Bob's not here, but we took the measure from Sternberg and Tulving, classic paper, for measuring the structure, the organization of memory. But what we've done here is to take that measure and change it into what my former graduate student, who's now a postdoc now, Adam Congleton, called SOMA. And I think that's just so appropriate, because now we are looking at the shape of the memory that people are developing, right? Shared organization metric analysis. So instead of looking at, so let me explain what that means. Partner A may recall Cherry Ranch sweater Jeep shirt. And usually in the classic paired frequency measure, it's recall 1 and recall 2 by the same individual, to see whether people maintain the same structure of a recall. Here we are comparing 2 different partners in a group to see whether they are demonstrating the same sequence, and to then compute the structure to see that these, here the fruits, they don't have to be from the same category for us. Actually, they can just be from, they just happen to co-occur. Okay?
So you're measuring subjective organization, but between subjects rather than within subjects.
Exactly. So they may have the same items that they have recalled, but if they don't co-occur, they don't get credit for having organized them into a structure. Okay? So that's the idea here. So instead of doing it sequentially, check, now we are doing it horizontally. Okay, so this is across two partners. So what we have here, this is the control condition, the likelihood of developing these structures, depending on, we had two recalls, so for the moment we can ignore it. That was for the purposes of the other study. But you can see that it's the same pattern. What we see is, the recall 5, by the way, occurred a week later, but the pattern is the same. When there's no collaboration, this is the level of soma, or structure of memory being the same. Collaboration, you can see, just takes the level of recalling information in the same structure to a much greater level than never having collaborated. And for that, you just need to look at these 3 bars being higher than this bar. And this is a week later, and the pattern is similar, but obviously everything is lower. So I just want to focus on recall 4 here. That is, immediate recall. So what we have is that collaborative recall increases not just shared content, it also increases the extent to which the organization of that content becomes shared. People are organizing information in the same way. Repeated recall does more so, and this advantage persists to some extent even after a delay. So how are we doing on time? 3 o'clock. I'm just going to very briefly mention to you a study that I have done in collaboration, where we have used an agent-based model to look at large social networks. And these are the 3 very well-known networks in the social network literature: Small World, Karate Club, and co-authorship, and they're of different sizes, as you can see. And the Small World is an algorithmically generated random graph, and these are the 2 empirically derived networks. And what we have here on the left side is a measure of collaborative inhibition when in this model we get the agents to interact with each other. So agents are imbued with memory and they interact with each other. And what we have here is nominal group recall. That's the baseline. And it hits ceilings. So after this, it's not particularly informative. And here we have collaborative group recall, and you can see that it runs lower. Even as the group size increases up to 7 or 8. And after that, it's a little bit difficult, even 16, but it's a little bit difficult to make sense of this because the nominal group recall has hit ceiling in the model. And what we have here is the similarity of what these agents are outputting. And you can see that the similarity persists up to 4 hops in the network. So I had shown you with the human data that you can have people not be neighbors but be coming together. And what we have here is in a model, these neighbors are up to 4 hops, showing some similarity in what the model generates as the output. So I began with telling you about how mnemonic transmission in a connected world can have implications for all these different possible real-life consequences. And what I tried to show you is that how we can bring these phenomena into the lab and control it fully, and then start to take it from dyads and triads of subjects where we control what they are receiving as information and measure what they are presenting to us as their memory, both collectively and individually, and then start to see how all of this then can be mapped to a very large set of people who can be then imbued with different properties, and to see how we can take well-known cognitive principles and ground them into these experiments, and then leverage them into taking them into much larger settings to understand how spread of memory can become a basis for understanding spread of behavior. So no talk is complete without acknowledging one's collaborators, much less a talk on collaborative memory, as I like to say. So I want to thank my collaborators who, in one form or another, have contributed to everything that I presented to you today. So thank you very much. It's been a pleasure. Steve?
Suparna, I was really struck by the theoretical model running. Would the implication be that in an interactive network, that what someone who was 4 hops away was doing would actually influence 4 hops forward? In other words, my friend's friend's friend is influencing me, even though I don't know my friend's friend's friend. Is that an implication of?
So that's sociologists are definitely talking about that pattern of influence in all of these social network analyses. I mean, they are really looking at it from such deep and computational perspective. The behavioral question is it just something we are seeing as a pattern, or is there something that we can call influence? And that's why we have become interested in the spread of information. So can we track whether what A and B together are saying, B and C said to each other, and that's why A and C know it? Right. So is there a connection? Yeah. And certainly in recall, there's connection. How that translates to behavior is the exciting part. Yeah.
So, as you know, there's a body of work in the adult literature suggesting that good is actually stronger than bad. Insofar as memory is concerned, individual memory, and I was wondering if you can speak to that in terms of your collaborative learning.
Yes. So actually, I made the bold statement that bad is stronger than good, and that comes from social psychology, and this is the opposite of it. And in fact, we think we have some window into why those two opposite conclusions can arise. We have a separate line of work that I didn't get into today, where we are looking at collaborative recall of autobiographical memories. So in the autobiographical memory literature, there's a phenomenon called fading affect bias, where as time passes on, people are more likely to remember positive aspects of that autobiographical memory. What we have done is created a paradigm where people collaboratively recall an autobiographical memory. And in this case, we have taken the autobiographical memory to be an exam event for students, because it has some affective variations. Some students come out feeling good, some people come out feeling not so good, and it gives us control over the event, because every single subject is recalling the same event, because the subjects who are in a particular collaborative group are assigned to that group for having taken the same exam, but not being previous friends. So they might know each other, they're in the same class, but Stony Brook has very large classes. So they know each other, but they're not personal friends, and they've taken the same exam, and we get them to collaboratively recall that exam event and create a narrative, either individually, from which we compute the similarities, or collaboratively. And what we see is, I know this is a long answer, but I'm actually getting to your question. Well, you just give me a chance to tell you about another study, so I won't miss it. So what we find is that there is a fading affect bias, such that individual recall repeatedly looks more positive, but that bias is greater if people get a chance to collaborate about that event, even though they're not friends, or at least they may know each other, but they are not personal friends. So there is good being stronger than bad when it comes to events that have personal affective relevance. But some of the negativity that we intuitively see in the spread of gossip and in social media, increasingly now, I'm saying that intuitively because I don't know how the empirical data turn out to be. But and what we see in the individual recall memory literature on valence, emotional valence, is that negative tends to be stronger. And so we see that accentuated in these paradigms, but we don't see that for autobiographical memory. So I think it really depends on what it is that people are remembering.
I guess I was just wondering if you could, like, this sort of age-based positivity effect found in
Yeah.
adults, if you could get to disappear, just simply got adults to collaborate.
I think that would be really very interesting. I think that would be very interesting that if we can get age-related positivity effect and collaboration to come together, largely because we're also interested in the effects of collaboration in aging. And we actually have a paper on it in Psychology and Aging, where we've looked at older adults' collaborative recall. And what we've established is that when the information is neutral, older adults look very similar to young adults in every measure that we could capture in that particular paradigm. So I think, to your point, looking at that in information that has personal relevance, the positivity effect could be very nicely accentuated with aging. Yeah, that's a very good possibility. I'll come to you in a second. Yeah.
Oh, yeah, so in terms of going back to the SOMA study that you're talking about, you looked at like the organization of like word neighbors. Did you also look at, so you said you used categorized words in that particular study?
In that particular study, we used categorized words. But in order to look at paired frequency, we looked at adjacent recall of items rather than categorized recall of items, because the sequence of, because we wanted to take the paired frequency measure and just flip it for dyads rather than within individual recall. But where are you going with it?
Yeah, so I was thinking, like, if you potentially looked at just like the clustering of categories when they recall of the collaborative group versus the non-collaborative group, and I'm just trying to get at like well, you see an increase in false memory, well, like, why can that happen? And if it's the case where you're getting like clustering in categories, then you might be more likely to also retrieve the
false information that fits the category. Yes, yes. We have looked at, so Adam, Adam Congleton, who's first author on that paper, is also lead author on a paper we published in 2011, also in JP General, where he looked at some of those questions, but I don't know if he looked at it exactly from that perspective, because we didn't have very high false memory recall in that. So I don't know that those data had the potential to answer the question that you're asking, but that's a good question, yeah. Yeah.
From the beginning of your talk, it seemed like you were proposing memory mechanisms that would account for some of these collective biases. And from the last modeling result, it seems like that model has nothing to do with memory mechanisms, right? As I understand the model, there's no retrieval inhibition built into it, no competition. And maybe you could explain more about that model, because that reveals that you find something parallel to the work from actual data, suggests that it has nothing to do with memory. It has all to do with social transmission.
No, thanks for asking that question. So let me answer that, and let me see if that is where what you're getting at in your question. So are you talking about the computational model that okay, so in that computational model, actually we built two mechanisms into it. Retrieval disruption. So when two agents are interacting with each other in the model, they are creating the same disruptive, quantitatively the same disruptive effects on each other, and re-exposure, which is that if two individuals talk to each other, if I didn't remember something I had seen, but you remembered it, and so now I later remember it, that we call re-exposure effect in our behavioral studies, and we built that into it. So in my behavioral work, we have tried to identify 6 or 7 mechanisms. The computational model uses only 2 of those. And it could use potentially more as we expand it, but those are the 2 mechanisms that are built into it, and those 2 mechanisms lead the model to exhibit the same pattern as our humans do. Yeah. Is that where you're going with it? Okay.
Yeah, that's
yeah.
And I guess the idea is how much the social part is revealing something about memory, Or is there a part of you that feels that are we learning more about social cognition? Are we learning more about memory?
Mm-hmm.
Are we learning about both? What's your take after doing this work? Is this social cognition you're presenting? Or
Yeah.
Is this memory, or does that distinction, you're just breaking up that distinction, we shouldn't be thinking of them separately?
Yeah, so I'm not, at present, I'm not categorizing these effects into any of these specific domains because I don't know that I have enough information to do that. I'm using cognitive mechanisms to explain or to even design studies where I can test some of these phenomena. The extent to which they are social, and my social psychologist colleagues can here say what that would be sort of the prototypical cases. That I think is an open question, number one. Number two, because we are seeing differences between autobiographical memory and information that's not personally relevant, I think there are distinctions. These are not just phenomena that come up because it's memory per se. It has to do with memory that has more, that's more than using a list of words. So once the personal relevance becomes important, then social relevance can be then ratcheted up. And I think that's when some of this friends, for example, so these are not data from my lab, but others have shown that when we look at these kinds of collaborative recall patterns among friends or long-term couples, collaborative inhibition comes down, but it does not disappear. The question is, why does it happen? The disruption that I talked about, the retrieval disruption, is clearly a strong force that is in operation. But over a period of time, people learn to align how they structure information. And that's potentially why people who have collaborated a lot have a certain alignment in their organization of information that they've come to accept, or they have agreed what social psychologists would call transactive memory. So, okay, if we are going to get this list, I know that you know more about fruits and vegetables, and I know more about cars. So I'm going to focus on that part, you focus on that part, and when we come together, we'll be able to do better than disrupting each other. So there's some of that goes on. So how much of it is social and how much of it is cognitive practice is an empirical question. But we can get some of these effects when we start to move away from these very controlled paradigms where some of the social factors are coming in. But to what I should ascribe them, I think is too early to say, at least based on the work that's currently in the literature. But I think this is the platform that can really take us to asking, are we looking at social cognition? Are we looking at cognitive effects that just happen to be in a larger setting? And how should we build these models so that mechanisms that are built into it have to do with either or both? I think that's really the path now. Yeah. Yeah.
So this may be a naive question, but I wonder if you could speculate what implications your work has for like machine learning. So do you think collaboration can be more effective in, say, human interactions, computer-computer interactions, or computer plus human interactions?
It depends on what mechanisms you're building into that interaction, right? Yeah. Yeah,
Right. So,
right.
The computers have sort of beaten the best chess player, but do you think there'll come a day when actually humans and computers interact to compete against each other?
What they do in chess online.
They do. I didn't mean to interrupt. Yeah, right.
But you mean like formally rank the? I think they do that to some extent. I know my son played a lot of computers. That's all I know.
I think a lot of it also has to do with how labile the two systems are that are interacting with each other. And how, I should say both labile and flexible. And they have two different implications for what will stay and what will disappear right? Labile, it can make it disappear, and flexibility will accommodate. And I think that's more of the question about the architecture, whether it's human architecture or whether it's machine architecture, that will likely predict whether the two can come to look similar or not. And I think, so there is a study out there that might interest you with humans, aviation experts, compared to novice pilots, not novice, hobby pilots, amateur pilots, and controls. And when they are given information about aviation scenarios, expert pilots show no collaborative inhibition, they show facilitation. Because they have such strong architecture for what that information already is, that any new scenario, instead of interfering, fits. And they're able to coordinate with each other for what fits and what doesn't fit, and then come up with a total scenario that shows no inhibition. And in that exact situation, controls show the standard inhibition in recall. So I think it really depends on human architecture. Cognitive architecture is not going to be the same across individuals. So I think those individual differences would be important to take into consideration when we compare it to machine learning. Yeah.
But the obvious, I know most of us were thinking fake news, right, during this all. Okay. Like the transmission of fake. Now, I think obviously that there's building blocks of social, because the effects when people are in groups and they're real people talking to each other are very different than when they're by themselves, doing these things by themselves. Well, something social is happening that's changing their behavior a lot. So you sort of at various points had asides that sort of were the beginnings of thoughts about this. But I'm sure people have asked you, what are your thoughts about fake news and information comes in? And we have narrowcasting now, where people don't necessarily listen to the same thing, but they hear about some of the same events, but then diverge in how they reconstruct them later.
So fake news and news is news as far as these kinds of memory effects go. Whether it's fake or real, it is impinging on the system. So then calling it fake versus real is it's almost a thresholding issue there that one has to use in order to say this is fake, and therefore I'm not. But once you've been exposed to it, your system is contaminated. It's there, and you have to have a particular a tag attached to it.
But at some point, if it's a false memory, that gets exacerbated in a group context.
Yes.
And say, you're emotional.
Yes.
Gee, that couldn't be politics. And then you study emotion and the interaction of people sort of reinforcing fake, maybe false memories.
Yes. So that's a classic effect of rehearsal. So when a particular news is receiving a lot of repetition, lot of talk, lot of chatter, and later on the context or the source of that chatter is lost, then it's just information. So then it's received a lot of rehearsal, and then unless a person is willing to recognize it as being fake versus not, it could, from a purely memory standpoint, it can come to have the same value. From whether or not it's real news, that's a different kind of dimension, I think. I mean, people clearly distinguish in our experiments, as you could see, the true memory bars are very big. The false memory bars are shorter. So it's not that people can't distinguish between real and false information. But I think we could change the stimuli completely, where it's very realistic for the false news to be completely consistent. You've shown that.
I might have done that.
So, I mean, it's how well the news fits into what the larger scheme of the real news is that makes it difficult to distinguish or not. And so here, we have categorized lists. We have the valenced information we have here is also actually categorized So some of it fits. You know, if you did not see tiger but you had seen cheetah, so you can really map out how far the fakeness goes from the realness. And we know that categories are very compelling in what we remember. So is that what you were getting at, or?
And
Well, we're nearly out of time, so let's thank Professor